Hi guys, this is AS Chemistry, Organic Chemistry, and we're doing alkenes. Question 1. The hydrocarbons A, C4H10, and B, C4H8 are both unbranched. A does not decolorize bromine. B decolorizes bromine and shows geometrical isomerism. Give the structural formula of B. So in B, we've got 4 carbon atoms and 8 hydrogen atoms. So there are two possible structures that can have this molecular formula, one of them being CH2 double bonded to CH, single bonded to CH2, and then single bonded to CH3. This is known as but1-ene. And then there is another one in which we have a CH3 group, single bonded to a CH group, double bonded to a CH group, which is single bonded to a CH3 group. So this is called but2-ene. In comparison, both of them will decolorize bromine water. However, but1-ene will not show geometric isomerism because it has two hydrogen atoms on the same carbon atom, whereas the compound but2-ene will show geometric isomerism or cis trans isomerism because the two carbon atoms with a double bond between them each have either a methyl group on them or a hydrogen atom on them, because of which there are two possible isomers, cis and trans, that can be made. Therefore, the correct answer here would be CH3, CH double bonded to CH and then single bonded to CH3, which is known as but2-ene. Explain why B shows geometrical isomerism. Due to the presence of the carbon-carbon double bond, there is restricted rotation because of which the two methyl groups present on both carbon atoms can either be located on the same side or on opposite sides of the double bond. So if both the methyl groups are located on the same side, then they cannot rotate and move to the opposite sides. And if they're already on opposite sides, they cannot rotate and move to the same side of the carbon-carbon double bond. Because of this, we have two isomers that are geometric isomers, a cis isomer and a trans isomer present for but2-ene. Draw the mechanism of the reaction of B with bromine. Include all necessary charges, dipoles, lone pairs, and curly arrows. So B is CH3, CH, double bond, CH, and then CH3. There will be a pi electron cloud around the double bond, and we will have a bromine molecule with one of the bromine atoms having a partial positive and the other having a partial negative charge due to uneven distribution of electrons at a particular moment in time. This allows for the pi electron cloud on the double bond to get attracted towards the partial positively charged bromine atom in the bromine molecule, which results in heterolytic fission taking place in the bromine molecule, producing a Br positive and a Br negative ion. The Br positive ion gets added onto the carbon-carbon double bond, which results in the heterolytic fission of the pi bond of the carbon-carbon double bond. So this forms the intermediate CH3, CH, CH3 with the Br positive ion added onto the carbon atom towards which the pi bond broke, and presence of a positive charge on the other carbon atom, making this compound a carbocation. The other species form would be the bromide ion, having the lone pair of electrons, which were originally the bonding pair of electrons on the bromine molecule. Next would be the attraction of this lone pair of electrons towards a positive charge on the carbocation, which results in the formation of the final product, which is 2,3-dibromobutane. This product is 2,3-dibromobutane, and this is the mechanism for the reaction of compound B with the bromine molecule. Explain the origin of the dipole on Br2 in this mechanism. So the pi electron cloud repels the electrons on the nearest bromine atom away from it, inducing a partial positive charge on it and a partial negative charge on the other bromine atom. Thus, the Br2 molecule is polarized by the high electron density of the pi bond. So that is how the partial positive and the partial negative charges or a dipole exists on the bromine molecule. Question 2. C60 forms hydrocarbons with similar chemical properties to those of alkenes. One such hydrocarbon is C60H18. State what is meant by the term hydrocarbon. A molecule made up of carbon and hydrogen atoms only. There are no other elements present in a hydrocarbon. Describe a test to indicate the presence of a double bond between carbon atoms in C60H18. Give the result of the test. So we add bromine water, which is also known as Br2 aqueous or aqueous bromine. And the result would be the brown color discharges. Or we can also write bromine is decolorized. Or we can also write the color changes from brown to colorless. Any one of these test observations would be sufficient for a positive test for the presence of the double bond. Question 3. The supply of material suitable for use as fuels directly from crude oil is not sufficient to meet demand. A process is carried out to make some of the larger hydrocarbon molecules more useful? Name this process. So this process is called cracking, in which larger hydrocarbons are broken down and made into smaller hydrocarbons, which are the more useful products. As well as producing fuels, this process produces compounds suitable for use in the production of polymers. An example of such a compound is butene. Draw the repeat unit of the polymer that is produced from butene. So the molecule of butene has a double bond between two carbon atoms, which would open up because it will produce an addition polymer. So these are the two carbon atoms that have double bond on them. And on each carbon atom, there is one hydrogen atom present and one methyl group present along with the hydrogen atom. And this is one repeat unit of butene. Name the type of polymerization that occurs during the production of polymer into, this is known as addition polymerization. Question 4. Nitrosyl chloride, NOCl, is a reactive gas that is sometimes formed when NO reacts with Cl2. And nitrosyl chloride has a partial positive charge on the nitrogen atom and a partial negative charge on the chlorine atom. NOCl is a strong electrophile and readily undergoes an addition reaction with alkenes. Complete the diagram to show the mechanism of the electrophilic addition reaction of NOCl with ethene. Include all necessary charges, lone pairs, and curly arrows, and the structure of the organic intermediate. So, in this compound, we have ethene reacting with nitrosyl chloride in this reaction. So, we have a pi electron cloud around the double bond, which will be attracted towards the positively charged nitrogen atom, because of which the NCl bond will undergo heterolytic fission as well as the carbon-carbon pi bond. And this will result in the formation of an intermediate in which we would have a hydrogen atom, in fact, two hydrogen atoms attached to each carbon atom, and the NO part of nitrosyl chloride attached to the carbon on the left, which means that the bond that is broken, the pi bond, will not be broken the way shown right now. It will be broken in the opposite direction because the positive ion would be attracted towards the carbon atom with a negative charge on it, and the head of the arrow, the curly arrow, represents the carbon atom having the negative charge on it. So the N positive will be added onto the carbon on the left. So this would result in the formation of N double bond O attached to the carbon on the left and the carbon on the right having a positive charge on it. This is the carbocation that is produced, and also the chloride ion having the lone pair of electrons, which was the bonding pair of electrons between the nitrogen and chlorine atom, present along with the carbocation. In the next step, this lone pair of electron is attracted towards the positive charge on the carbocation, and it gets added onto it, producing the final product as shown in the given mechanism product. Question 5. Carbon atoms can form sigma and pi bonds within hydrocarbon molecules. Explain the following statement with reference to sigma and pi bonds. Alkenes react with electrophiles, but alkanes do not. So alkanes have only sigma bonds present. Alkenes have a pi bond present along with the sigma bonds. The pi electron cloud gets attracted towards electrophiles and thus alkenes undergo an electrophilic addition reaction because of this. So the pi electron cloud, when it is attracted towards the electrophile, it adds the electrophile onto the carbon atom that had a double bond. The double bond breaks, forming a single bond with the electrophile and a positive charge on the other carbon atom. A nucleophile adds on to the other carbon atom, completing the formation of the new product. Question 6. The gas ethine, more commonly known as acetylene, is manufactured for use in the synthesis of organic compound. It is also used in combination with oxygen in oxyacetylene torches for cutting and welding of metals. Industrially, ethine is made from calcium carbide, CaC2, or by cracking liquid hydrocarbons. When calcium carbide is reacted with water, ethine and calcium hydroxide are formed. Construct a balanced equation for this reaction. So we have calcium carbide, CaC2, reacting with H2O, producing calcium hydroxide, which is CaOH twice, and production of C2H2. So in order to balance this equation, we need one atom of calcium and two atoms of carbon, which are already there in the reactants. And altogether, we need four atoms of hydrogen and two atoms of oxygen, which can be included by making the molar coefficient of water as 2. So 2 moles of water react with 1 mole of calcium carbide, producing 1 mole of calcium hydroxide and 1 mole of ethine gas. Ethine can also be obtained from ethene by using the following sequence of reactions. So we've got ethene converted into 1,2-dichloroethene, ethane, 1,2-dichloroethane, which is converted into ethine. What type of reactions are steps 1 and 2? So step 1 is electrophilic addition. Cl2 molecule gets added onto C2H4. And step 2 is an elimination reaction in which two hydrogen atoms and two chlorine atoms are removed. This elimination can also be known as dehydrohalogenation because hydrogen and halogen are both removed. Suggest what reagents and conditions would be used in a lab in step 2. So dehydrohalogenation requires the reagent NaOH to be present and the conditions would be ethanol. So NaOH plus ethanol will result in the production of ethine from 1,2-dichloroethane. When ethine is passed into water at 60 degrees Celsius, the presence of a little H2SO4 and mercury ions, a pungent colorless organic liquid Q with MR of 44 is obtained. This is step 3. So ethine is passed into water in the presence of a little H2SO4. Okay. When Q is warmed with Tollens reagent in a test tube, a silver mirror is formed. So Q is an aldehyde. On acidification, the solution remaining in the test tube is found to contain the organic compound R, which has the MR of 60. This is step 4. So on acidification, so when we acidify the Tollens compound that reacted with Tollens, that means the aldehyde, it would convert into an organic compound with an MR of 60. So the difference between 44 and 60 is 16. So an oxygen atom is added. So in aldehyde, we've got one oxygen atom and the product has two oxygen atoms, which means it is converted into a carboxylic acid. So give the structural formula of Q and R. So we've got a 2 carbon ethyne, which is converted into an aldehyde. So the aldehyde should be CH3CHO. And in order to check if this is correct, we calculate the MR. So 12 to the 24, 24 plus 16 is 40 and plus 4 is 44. So this is correct. And it is converted into a carboxylic acid, which would be CH3, CO and OH, and 44 plus 16 gives 60. So what type of a reaction is steps 3 and step 4? Step 3 would be an addition reaction because we have two carbon atoms. We've got four hydrogen atoms and one oxygen atom. So two hydrogen and one oxygen has been added onto the ethyne molecule. So this is an addition reaction. And step 4 is conversion from aldehyde to carboxylic acid, which is known as oxidation. Question 7. Oleic and elladic acids are examples of monounsaturated acids. Many vegetable oils contain esters of polyunsaturated fatty acids. Such oils are often hydrogenated to form esters containing saturated or monounsaturated fatty acids. Suggest the meaning of the term polyunsaturated fatty acid. So, poly means multiple, unsaturated means presence of a double bond, double or triple, but mostly double. So, polyunsaturated fatty acid is a fatty acid that contains more than one carbon-carbon double bond. So that is why it is polyunsaturated. What reagents and conditions are used for the hydrogenation of an unsaturated fatty acid? So the reagent used is hydrogen and the conditions used are nickel catalyst at 150 to 200 degrees Celsius. So that would result in hydrogenation of the carbon-carbon double bond, or in this case, hydrogenation of the polyunsaturated fatty acid. Question 8. The compound trans-4-hydroxy-2-nonenal HNE is thought to lead to infections of the lung when cigarettes are smoked. And its skeletal formula and its condensed structural formula are given. How would you confirm the presence of the alkene group in HNE? So the reagent used would be aqueous bromine, which is Br2 aqueous, and the observation would be brown color is discharged. Give the structural formula of all of the carbon containing compounds formed in each case when HNE is reacted separately with the following reagents. Hot concentrated manganate 7 ions in acidic solution. So this and this, no, only this double bond would break. And this is the aldehyde group. And this is the secondary alcohol group. which would be oxidized. So the product form would be CH3, CH2. This would be 1, 2, 3, 4. 4 CH2 groups in a continuous chain, followed by a C, which would convert into a ketone because it is a secondary alcohol, and then we would have a COOH group present along with the ketone group in one of the products, and the other product would be COOH bonded to COOH because the aldehyde would also be oxidized. So this is ethane 1,2-dioic acid, also known as oxalic acid. So this will not be the final product because this undergoes oxidation. So this compound would be oxidized to produce CO2 and H2O. So the final products would be the product drawn on the left and carbon dioxide as the carbon containing products of the reaction of trans 4 hydroxy 2 nonenal with hot concentrated manganate 7 ions in acidic solution. Question 9. One method of preparing ethene in a school or college lab is from ethanol by using the apparatus shown. So we have a mineral wool dipped in ethanol. We strongly heat it. It passes through pumice, which is Al2O3, and is collected over water as ethene. Write a balanced equation for this reaction. So this reaction is the conversion of ethanol, which is CH3, CH2OH into ethene, which is CH2 double bonded to CH2, and we have removal of water, and the other product would be H2O. So this is dehydration of alcohol. What type of a reaction is this? It is an elimination reaction, which is also known as dehydration. Give the chemical name of a reagent other than pumice that could be used to carry out the reaction. It is not necessary to use the same apparatus. So we can use concentrated H2SO4 at 170 to 180 degrees Celsius to carry out dehydration of alcohols. Ethene is bubbled into two separate test tubes, one containing aqueous hydrogen bromide and the other containing cold dilute acidified potassium manganate 7. In each case, describe any color changes you would see and give the structural formula of the organic product. So color at start, aqueous hydrogen bromide, colorless, and color after reaction will still be colorless. And structural formula of the organic product. So we have HBr adding on to ethene producing CH3, CH2, Br, bromoethane. And with cold dilute acidified potassium manganate 7, color at the start would be purple. Color after the reaction would be, we'll have two particular colors that can happen. We can either have a colorless solution or we can have appearance of dark brown precipitate. Since both of these reactions are possible, both of them have been listed here. And structural formula of the organic product, this will be a diol. So it will be ethane 1,2-diol. So OH, CH2, CH2, and OH. Cyclohexene has the following structural formula. What is the molecular formula of cyclohexene? So this contains 6 carbon atoms and 2, 4, 6, 8, 9, and 10 hydrogen atoms. Draw the structural formula of the compound formed when cyclohexene is reacted with bromine. So bromine will add on to both the carbon atoms with a double bond on them. So this will result in the double bond no longer being present. Instead, both carbon atoms that had the double bond will now be bonded to a bromine atom. State as fully as you can what type of a reaction this is. This is an electrophilic addition reaction. Draw the structural formula of the compound formed when cyclohexene is reacted with hot concentrated acidified potassium manganate 7. So the double bond will break, resulting in the formation of a compound with two COOH groups present on both the carbon atoms that had the double bond between them. So the name of this compound would be 1, 2, 3, 4, 5, 6. It would be hexane 1,6 dioic acid. Question 10. CH3CH, double bond CH and COOH will react with a solution containing acidified manganate 7 ions. Draw the structural formulae of the organic products when the reagent is cold and dilute. So this results in the formation of a diol. So the product would be CH3, CHOH, CHOH, and COOH. And the name of this product would be 1, 2, 3, and 4. So it will be called 2, 3 dihydroxy because the OH groups are substitute groups here. Butanoic acid. And when the acidified manganate 7 ions are hot concentrated, the double bond will completely break, resulting in the formation of CH3, COOH, which is ethanoic acid, and a molecule of COOH bonded to COOH, which is ethane 1,2-dioic acid, which undergoes further oxidation to produce CO2 and H2O. So the final products of this reaction would be CH3COOH, CO2, and H2O. And CH3COOH is ethanoic acid. And the other acid form that undergoes further oxidation is called ethane 1,2-dioic acid, which is also called oxalic acid. And oxalic acid is further oxidized to CO2 and H2O, so it is not the final product of this reaction.